Hi everyone. In this video, I would like to briefly go over the correct mechanism and the incorrect mechanism. And after playing with ChemSketch for a little while, I've learned that drawing the correct mechanism can be quite a challenge, let's put it that way. So I want to show you a few tips as far as the software. So basically what I've done so far is I've opened up my file to exactly where we left off, which is the correct separation scheme. And now I'm going to put in the incorrect mechanism. Whoops, here. And since it's a title, I'm just going to go ahead, make it bold, make it a little bit bigger. So I suggest you do the incorrect mechanism in a very similar way to how you did the incorrect separation scheme. So there's the incorrect separation scheme. Here's the incorrect mechanism. So I have opened this with Adobe Acrobat Reader, and I'm just going to make it so it fits on the screen. And what I want to do is I want to go ahead and edit, take a snapshot, and then I'm going to paste it into Word. Notice that it says, although the elimination may be the major product, focus on the substitution product. So you can copy that or not, that's fine. And I'm just going to go ahead and copy it. If you prefer not to copy that and just remember it, you can do that as well. So I went to edit, take a snapshot, I took a snapshot, that puts it in my clipboard, and then I can paste it in here. It doesn't paste over very well, it looks a little bit fuzzy, so that's basically that. But we can still do the same thing we did before. We can insert a text box, we can draw our text box, and we can do step 1. I'm going to make that a little bit bigger, and I want no outline here, so I'm going to put no outline. So step 1, and then I can Control C, Control V, step 2, and then finally Control C, Control V, step 3. So I've essentially labeled each of the steps of the mechanism, and now I'm going to say what's wrong with them. In many of the mechanisms, there's lots of things wrong with them in each step. So I suggest that we focus on one thing. So let's take a look here at step 1. So in step 1 of this mechanism, remember that it says focus on the substitution product. So methoxide here is going to substitute bromine, because it's an alkyl halide. Also notice that I have my molecule drawn as R and R prime. I have a carboxylic acid on one side and stuff like this, but basically I'm not going to worry about that. So I'm just going to leave them as R so I can focus on the important part in the mechanism. So here methoxide goes and takes this hydrogen. Well, even if this was an elimination, it wouldn't take that hydrogen, it would take the adjacent hydrogen on this carbon right here, or this carbon right here, depending on Zaitsev's rule, for which one it would take. With R and R prime, it's hard to tell. So here, this is not going to take off this this carbon. So essentially, in this case, let's identify this as a nucleophile or an electrophile. So we have a negative charge. So this is going to be a nucleophile. The nucleophile methoxide would not attack the hydrogen attached to the alkyl halide. Instead, it would attack the carbon attached to the alkyl halide. So in a substitution reaction, this nucleophile is going to attach this carbon. Why? Because this is partially negative, because it's more electronegative than carbon, and this is partially positive. So this is going to come in here and kick this guy out. Because this would give a secondary carbocation, it's probably going to go through an SN2 mechanism and not an SN1 mechanism. Said another way, you'll get a transition state. So in this case, instead of this attacking here, this is going to attack here. There are other things wrong with this, but that is fundamentally the case. Now, let's consider step 2 independent of step 1. So we're just going to look at this. If some how we had this carbocation. It's going to be incredibly unstable, right? Because we have this bromine attached to this carbon, and this is electron withdrawing, and that's going to further destabilize this positive charge. But if it happened, now we have methanol attacking here. Okay, so this is, I guess, theoretically possible, although you wouldn't really have this carbocation forming. But what you notice in step 2 is what's attached. What's attached is the carbon and not the oxygen. So carbon is certainly not going to act like a nucleophile here because it doesn't have electron density. Oxygen is going to act like the nucleophile. So again, there are lots of things wrong with this, but in step 2, the thing I'm going to focus on, and I suggest you focus on one thing in each step, you don't need to focus on all the stuff that's wrong. In this case, I'm going to say the carbon of methanol would not act as the nucleophile, and the thing that Word knows how to spell, and the product has a 5 bonded carbon. So if we look here, this carbon is bonded to 3 hydrogens, an oxygen, and a carbon. So we have a 5 bonded carbon here. Okay, so that is fundamentally incorrect. Step 3. In step 3, we can say, well, if we ignore this 5 bonded carbon and the fact that this carbocation still exists somehow, because this, substituted and you still have a plus charge, which isn't the way that it works, would this attack? Theoretically, yeah, theoretically this could happen. However, you wouldn't get this stereospecific case, because in this case, when you have this plus charge, this molecule is no longer chiral, so therefore you don't get this stereoselective center, so you can focus on that if you want. But I'm just going to stay in step 3. This is theoretically somewhat possible if you ignore the 5 bonded carbon. Bromide can act as a nucleophile, and I keep putting that E in there, nucleophile, and a carbocation is an electrophile. Then finally we can say something about, if you wanted, you could say something about the inversion of the stereochemistry would not happen. The inversion, well, not inversion, the stereoselectivity in this case is not possible. Again, here it's not a big deal if you ignore this stereoselectivity part, but fundamentally if you have bromide and a carbocation, they can react. So if you focus on that, I think it's good enough. If you want to add things like this, that's okay as well. So now that we've looked a little bit at the incorrect mechanism, and to focus on the step 1, step 2, step 3 part, let's go ahead and draw the correct mechanism, which can be a little bit of a pain in the neck, as I said, using but ChemSketch. So I just want to kind of go through that briefly, and even though it took a few minutes to do it, it's not going to take an hour, so it's not a huge big deal, but I do want to go through that next. So before I go over how to draw this in the software, I'd like to start by drawing this on a piece of paper. So in this case, I have a carbon bonded to an R prime, a bromine, and a hydrogen. And I'm going to kind of ignore the stereochemistry here for simplicity. At first, I was going to try to draw it in and focus on the inversion of the stereogenic center, but for simplicity's sake, I'm going to skip that. So I'm going to add to this methoxide, CH3, CO minus. That's methoxide. And I'm going to get this in the presence of methanol, CH3OH. So in this case, methoxide is we're going to focus on the substitution reaction, and methoxide is going to act as a nucleophile. Well, this bromine is partially negative and this carbon is partially positive. So this negative methoxide can attack the carbon of the attached to the alkyl halide. And what you end up with is this transition state where you have R bond C, you have Br leaving, you have H, you have methoxide attacking, and you have R prime. And this is a transition state. Then finally, what you have is R bond C, bond H, bond O, CH3, bond R prime, plus bromide, which is just negatively charged bromine, like this. Technically speaking, a lot of times these are reversible reactions, so if you want to use reversible arrows, that's useful. You can use them like this, or you can use them like that. It doesn't really matter. For the software purposes, there are more technical ways to do this, but for the software purposes and the basically the simplicity, we're going to kind of do it this way. So this is the mechanism. At the end of the day, methoxide replaces bromine. You get a transition state. Said another way, this is an SN2 mechanism, and you end up with methoxide attached and bromine coming off. I did not focus again on the stereochemistry. So now I need to draw this in Chemdraw. So to draw this in Chemdraw, or ChemSketch, I actually want to first open up a blank screen. And what I want to do is draw my carbon. And I want to draw first an R. Whoops, I didn't mean to do that. So I want to draw a carbon, and then I want to bond it to an R. So I think if I do it like this, it will work out better. So I'm going to draw 4 like that. I'm going to go ahead and select all of it. That didn't work out too well, so I'm going to square select it. I'm going to make it look halfway decent, and now I'm going to change these things. So this is an R, this is an R prime, so just get an R1, put that there. One of these is a bromine, and one of them is a hydrogen. So that is essentially my molecule, and that's going to interact with methoxide. So I'm going to draw an oxygen, I'm going to draw a carbon like that, and I'm going to go ahead and put a minus charge on this like this. To write a plus sign, I click on the T and I put a plus like that. So that gives me my reaction. The next thing that I need is an arrow. So I can use an arrow like that. And on top of my arrow, I'm going to put CH3OH, which is methanol, which is my solvent. And I want this subscripted, so I use this text selector and I subscript that like so. And then I'm just going to grab it and put it like that. So here is my mechanism. Now I need to draw arrows. It turns out that drawing arrows on this software is not super easy. So if I go to the draw function, I can draw a curved line like that, but drawing an arrow onto the end of it is a bit of a problem. So instead, what I do is I grab the arrow tool, I don't know what that is, and I just kind of, oh, that didn't work. So I just kind of, grabbing the arrow tool, just kind of draw an arrow at the end of my curved line. Why didn't that work? Let's try again. So there we go. Now I have an arrow at the end of my curved line. Now I want to try to draw the transition state. And it turns out that this is a bit of a pain in the neck. So the first thing I want to do is I want to go to structure and I want to grab, whoops, I hit the wrong button. So I want to grab this structure. I'm just going to hit Control Z to get rid of that. I'm going to go back to structure, grab this structure, Control C, Control V. I'm going to put it right there. I'm going to go ahead and get rid of that line. I somehow lost my arrow, so I'm going to go ahead and put that back in like that. Now that I have my structure like this, I want to draw this transition state. To do that, I want to change this to a dashed line. So I'm going to click on the dashed line and click on that like that. And what you'll notice is that kind of messed up this. I also want to put a dashed line like this, and I want to connect it to this. So I'm going to change this to an O, and then I'm going to change this to a CH3 like this. And what you'll notice is all of these things have extra H's in there. So what I want to do is I just basically want to grab this, and then I want to do object properties. And here I want to click on atom, and then when you click on this, you can click on just H or just C, doesn't matter. And then where it says show, click on that like that. Hit apply. So it disappears. All right. Same thing here. I'm going to go ahead and do object properties on this. And I'm going to click on just one of them. Click on show. Hit apply. Oh, that's the one I want to get rid of. So I want to go back over here where this is. And what I want to do, I hit the wrong one. I want to go to object properties. I want to show this C. I don't want to show the H. I want to show this C. So I'm going to show that. Hit apply. And then here, same thing. Go to object properties. Go to just the H. So highlight just the H. Click show. Hit apply. And now it disappears. And now I have my transition state. Now, to label this as a transition state, put it in brackets. I grab the bracket tool, put the brackets around it. Then I need a line, so I need the double daggers here. So I'm just going to build that, and then build that, and then Control C, Control V, and put the second line exactly in the same spot. So that doesn't look exactly perfect. It'd probably be better if I just move that over. I'm just going to use my arrow key, move that over a little bit, close enough. All right, now that I have that, I can go back over here and draw another line, like so. This time, I want to grab my original molecule, so I'm going to click this, hit Control C, Control V, get this here, get rid of the little arrow again, and the little line. And this time, I want to change this to an OCH3, so I change this to an O, and I add the methyl group like this, and then I add Br over here, and I put a minus charge on it like this. In order to put in a plus, you have two choices. You can either grab this one, Control C, Control V, and put it in there like that. If you like to have reversible arrows, you can put these all in as reversible arrows, which you can actually use reversible arrows. So you can just use something like that. And if you like that better, you can do it like that. But we're not going to be super picky about whether you have the right reversible arrows or something like that. The major trick that you have to remember is how to get rid of the extra H's when you change to the dashed bond. And to do that, you need to click on the atom, click on object properties, click on atom, get the H, and remove the show. So the H does not show up and you don't see it, and that makes it disappear. So I hope that you found this video helpful and how to draw these corrected mechanisms. But basically, once you've drawn it, all you can do, take it, copy the whole thing, and I didn't want that. I wanted to put it here and just paste it into your Word file. Once you've done that, paste it in that correct mechanism, you're done. And you have completed all the sections of the molecule project. Thank you very much for watching, and have a good day.